Chapter 36 of Astronomy, the Science of Heavenly Bodies by David Todd. The Giant Planet. I can never forget as a young boy my first glimpse of the planet Jupiter and his moons. It was through a bit of a telescope that I had put together with my own hands, a tube of pasteboard, and a pair of old spectacle lenses that chanced to be lying about the house. In the field of view, I saw 5 objects, 4 of them looking quite alike, and as if they were stars merely. They were Jupiter's moons, while the 5th was vastly larger and brighter. It was circular in shape, and I thought I could see a faint darkish line across the middle of it. This experience encouraged me immensely, and I availed myself eagerly of the first chance to see Jupiter through a bigger and better glass. Then I saw at once that I had observed nothing wrongly, but that I had seen only the merest fraction of what there was to see. In the first place, the planet's disk was not perfectly circular, but slightly oval. Inquiring into the cause of this, we must remember that Jupiter is actually not a flat disk, but a huge ball, or globe, more than 10 times the diameter of the Earth, which turns swiftly round on its axis once every 10 hours, as against the Earth's turning around in 24 hours. Then it is easy to see how the centrifugal force bulges outward the equatorial regions of Jupiter, so that the polar regions are correspondingly drawn inward, thereby making the polar diameter shorter than the equatorial one, which is in line with the moons or satellites. The difference between the 2 diameters is very marked, as much as 1 part in 15. All the planets are slightly flattened in this way, but Jupiter is the most so of all, except Saturn. The little darkish line across the planet's middle region or equator was found to be replaced by several such lines or irregular belts and spots, often seen highly colored, especially with reflecting telescopes, and they are perpetually changing their mutual relation and shapes because they are not solid territory or land on Jupiter, but merely the outer shapes of atmospheric strata blown and torn and twisted by atmospheric circulation on this planet. Quite the same as clouds in the atmosphere on the Earth are. Besides this, the axial turning of Jupiter brings an entirely different part of the planet into view every 2 or 3 hours, so that in making a map or chart of the planet, an arbitrary meridian must be selected. Even then, the process is not an easy one, and it is found that spots on Jupiter's equator turn round in 9 hours and 50 minutes, while other regions take a few minutes longer, the nearer the poles are approached. The Great Red Spot, about 30,000 miles long and a quarter as much in breadth, has been visible for about half a century. Bolton, an English observer, had made interesting studies of it very recently. The 4 moons, or satellites, which a small telescope reveals, are exceedingly interesting on many accounts. They were the first heavenly bodies seen by the aid of the telescope, Galileo having discovered them in 1610. They travel round Jupiter much the same as the moon does round the Earth, but faster. The innermost moon about 4 times per week, the second moon about twice a week, the third or largest moon, larger than the planet Mercury, once a week, and the outermost in about 16 days. The innermost is about 260,000 miles from Jupiter, and the outermost more than 1,000,000 miles. From their nearness to the huge and excessively hot globe of Jupiter, some astronomers, Proctor especially, have inclined to view that these little bodies may be inhabited. Jupiter has other moons, a very small one close to the planet, which goes round in less than 12 hours, discovered by Barnard in 1892. 4 others are known, very small and faint and remote from the planet, which travel slowly round it in orbits of great magnitude. The 9th, or outermost, is at a distance of 15.5 million miles from Jupiter, and requires nearly 3 years in going round the planet. It was discovered by Nicholson at the Lick Observatory in 1914. The 8th was discovered by Malott at Greenwich in 1908 and is peculiar in the great angle of 28 degrees, at which its orbit is inclined to the equator of Jupiter. The 6th and 7th satellites revolve around Jupiter inside the 8th satellite, but outside the orbit of 4. And they were discovered by photography at the Lick Observatory in 1905 by Perrine, now director of the Argentine National Observatory at Cordoba. The ever-changing positions of the Medicean moons, as Galileo called the 4 satellites that he discovered, their passing into the shadow and eclipse, their transit in front of the disk, and their occultation behind it, form a succession of phenomena which the telescopist always views with delight. The times when all these events take place are predicted in the Nautical Almanac, many thousand of them each year, and the predictions cover 2 or 3 years in advance. Jupiter, as the naked eye sees him high up in the midnight sky, is the brightest of all the planets except Venus. Indeed, he is 5 times brighter than Sirius, the brightest of all the fixed stars. His stately motion among the stars will usually be visible by close observation from day to day, and his distance from the Earth at times when he is best seen is usually about 400 million miles. Jupiter travels all the way around the Sun in 12 years. His motion in orbit is about 8 miles a second. The eclipses of Jupiter's moons, caused by passing into the shadow of the planet, would take place at almost perfectly regular intervals if our distance from Jupiter were invariable. But it was early found out that while the Earth is approaching Jupiter, the eclipses take place earlier and earlier, but later and later when the Earth is moving away. The acceleration of the earliest eclipse added to the retardation of the latest makes 1,000 seconds, which is the time that light takes in crossing the diameter of the Earth's orbit around the Sun. Now, the velocity of light is well known to be 186,300 miles per second, so we calculate it once, and very simply, that the Sun's distance from the Earth, which is half the diameter of the orbit, equals 500 times 186,300,000, or 93 million miles. End of section 36.